So we've already learned two ways to solve for roots of the quadratics besides finding them on the graph or the table on the calculator. So we've learned to solve them by factoring and to solve by square root. So today we're going to learn what's called the quadratic formula. You could use the quadratic formula every time. It will work on every quadratic, but it's kind of clunky for the ones that could be solved really easily by squares or factoring. So we don't really want to use it every time, although we could. I could show you why it works, but I'm not going to do that today. So instead of showing you why it works and where it's not a magic formula that someone just made up, you can actually derive it. That means, you know, infer it, deduce it from something else. But right now I'm just going to teach it to you. So standard form of the quadratic equation, which we've talked about and is on your formula chart, ax squared plus bx plus c equals 0. The quadratic formula is this, x standing for the x-intercepts, of course, where x is 0, the roots, the solutions, the zeros. We have to know a, b, and c in order to substitute into this formula. Before you can identify a, b, and c, the equation must look like this. It must be equal to 0. So let me just dive in and show you an example of it. Right here. Here's a quadratic. It is set equal to 0. So first we identify a, b, and c. A is the one attached to x squared, so it's 2. B is the one attached to x. Don't forget that the minus goes with it, making it a negative 5. C is the constant, negative 12. So all of this is a substitution. You should know how to substitute. We've substituted for years. Let's go up here. I've got x equals negative b. So negative has to stay there, and then substitute b. Well, b is a negative 5. So you're going to have a negative negative, which some of you will automatically change that to positive, and that's fine. But make sure you know that the negative goes in the formula, and then the b, even if it's negative, goes right there. Plus or minus, that's what this means. Remember how I told you that square roots have two answers, a positive and a negative. That's what this means. I've got a plus and a minus. The square root of b squared, now make sure you put that b in parentheses or it's going to give you the wrong answer. You're telling your calculator the wrong thing if you don't put that in parentheses. Minus 4a, here's a, c, and then you divide it by 2 times a. So let's simplify this. First of all, do not try to put plus minus in your calculator. You cannot do that. We're getting two different answers. Negative negative turns to positive. What is the square root, negative 5 squared? You could put that in your calculator. The minus 4 times 2 times negative 12, you could put in your calculator. Here's what I would recommend. I would recommend putting this whole thing under the radical in your calculator to get the 121. Don't put the radical in there. Put the whole thing, and I'll show you why later. Put the whole thing just like that in your calculator, and it'll give you the 121. So yesterday we did, or not yesterday, one day this week, we did square roots. Square root of 121 is 11. We love it when they're a perfect square because that makes our math much easier. Now I have two problems. I have 5 plus 11 is over 4 or 5 minus 11 over 4. Reduce those. You actually could put that in your calculator if you wanted to and get your reduced fraction. So your roots are 4 or negative 3/2. So let's do one ourselves. On this one, there is no number in front of x squared. So we know there's an imaginary 1, so a is 1. B is 2, c is negative 35. I should have checked first to see if it was equal to 0, and it is. So I also should make you sing the quadratic formula. You can sing it to Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So, oh, don't worry, we'll sing that in class. So negative b is 2, plus or minus the square root of b squared minus 4ac over 2a. So all I did on that step was substitute. I went ahead and made the shell here of the formula for you, and all you did was plug in. Now let's simplify. Negative 2 plus or minus the square root of, I'm just going to go ahead and stick all of that in my calculator so I can show you what I mean by that. So what do I have? I have, now remember, parentheses, 2 squared minus 4, parentheses, 1, parentheses, negative 35. So let me turn off that light. Maybe that'll help. Nope. Right there. I typed that in. Remember, look, I didn't put the radical. I just typed that whole thing in and I get 144. Oh, I can recognize that 144 is a perfect square, which is awesome because it's going to make my math so much easier. 2 times 1 is 2. So, negative 2 plus or minus square root of 144 is 12 over 2. At this point, if you want to put the 2 different problems in your calculator, you can, because I'm going to move it over here. I have negative 2 plus 12 over 2, and then I have negative 2 minus 12 over 2. So this gets me 5, and this gets me negative 7. So there are my roots, negative 7 and 5. I'm going to do one more here. I'm going to skip down here and do number 4. So it's not equal to 0. So the very first thing I have to do is set it equal to 0. Do not identify A, B, and C until it's equal to 0. So to do that, I need to get rid of the 5 by minusing it. So that makes 2x squared minus 9x minus 5. So what is A? A is 2. B is negative 9. C is negative 5. Plug in negative B. B is already negative, so I need my negative negative. Negative 9 squared. Be sure it's in parentheses. A, C, A. So now negative negative becomes positive. 2 times 2 is 4. Let me put this part in my calculator. So I can do that. 121. Perfect square. So then I get 9 plus 11 over 4, because the square root of 121 is 11, or 9 minus 11 over 4. So that gives me 5 and negative 1/2. Those are my roots. So that's how we substitute and solve using quadratic formula.